Rogue planets, also known as free-floating or orphan planets, are fascinating objects in our universe because they don't orbit any star. Instead, they drift alone through interstellar space. So how do rogue planets form? There are two main ways. Ejection from a star system. Most rogue planets start out orbiting a star just like other planets. However, during the chaotic early stages of planetary system formation, gravitational interactions can be so intense that some planets get kicked out of their original system. Think of it like a cosmic game of billiards. These planets are flung into the vastness of space. Alternatively, some rogue planets might form directly from collapsing gas clouds in space, like how stars are born, but without enough mass to ignite nuclear fusion. These are sometimes called subbrown dwarfs, but if they have enough mass, more than about 13 times that of Jupiter, they qualify as rogue planets. Now, let's talk about their characteristics. Rogue planets can be huge or small, ranging from a few times the mass of Earth to several times the mass of Jupiter. Since they don't orbit a star, they tend to be very cold on their surfaces. But interestingly, they can still retain internal heat from their formation process or radioactive decay, which might keep some subsurface layers warm. Detecting rogue planets is quite challenging because they don't emit light. Scientists mainly rely on these methods. Gravitational microlensing. When a rogue planet passes in front of a distant star, its gravity bends and magnifies the star's light, revealing its presence. Infrared observations. These planets emit faint thermal radiation, which sensitive infrared telescopes can sometimes pick up. Direct imaging. Very few rogue planets have been directly observed due to their faintness and the vast interstellar distances. Why are rogue planets important? Well, research suggests there could be billions or even trillions of them in our galaxy alone, the most numerous objects in the universe. They also raise interesting questions about the possibility of life. Although these planets are extremely cold and isolated, some might have subsurface oceans beneath thick ice layers, for example, Jupiter's moon Europa, potentially harboring microbial life. At the end of the day, rogue planets are cosmic wanderers, free-floating worlds born from violent ejections or silent formation. They challenge our understanding of planetary systems and open new avenues of exploration for astronomy and astrobiology.